Okay, so now we're going to look at focus question D. So are all atoms of an element the same? So our first thought, and like according to Dalton's theory, was that all atoms of an element were the same. What I'm going to tell you now is that there are several different types of the same element. So for example here, you can see that we've got this first table about carbon atoms. So carbon 12 is something you might have heard of before. It's used for like dating materials and stuff like fossils and such. Same thing with carbon 14. Carbon 11 and carbon 13, not quite as common, not something you might have heard of as much. But they're all carbon, but they have different mass numbers. So this one has a mass number of 11. This one has a mass number of 12. This one has a mass number of 13, and this one has a mass number of 14. So these mass numbers are different. But what has to be the same about them is their atomic number. Because if it's not the same atomic number, then it's not the same element. So if all of them are carbon, if you look on the periodic table, carbon is number 6. So it doesn't matter which type of carbon we have, they're all carbon, they're all the same atomic number. So we know that atomic number and number of protons are the same. So we can see that no matter which carbon we have, they have the same atomic number, they have the same number of protons. Because those two things, remember we learned yesterday, are what identify an element. So if they don't have the same atomic number, then they're not the same element. Remember that protons and electrons, when we have these neutral atoms, are equal to each other because the positive and the negative charges have to balance out. So we also have 6 electrons. Now here is where the difference is going to be. Because remember, we just talked about that in order to get the number of neutrons, you take the mass number minus the atomic number. And that's because the mass number is protons plus neutrons. The atomic number is just protons. So if I take protons plus neutrons minus the number of protons, I'll be left with the number of neutrons. So for the first one, 11 was the mass number, 6 is the atomic number, so 5 neutrons. The next one, the mass number is 12, the atomic number is 6, so 6 neutrons. Next one, the mass number is 13, atomic number is 6, so 7 for the number of neutrons. And the last one, 14 is the mass number, 6 for the number of neutrons, so we have, or 6 for the atomic number, 8 for the number of neutrons. So you can see that if we have these different types of carbon, they have different mass numbers, same atomic number. Same number of protons, different number of neutrons. So what do you notice about the different carbon atoms? What's the same? So the same atomic number and number of protons. And what's different about them is their mass number and their number of neutrons. Okay. So that's what we call, if you see down here, an isotope. And you probably heard that word before, maybe like in a movie or something like that. So isotopes are the same element, but they have, so the same atomic number, but a different mass number. So a different number of neutrons. All right, so let's look at the magnesium. So for magnesium, there's 3 different types of magnesium. Magnesium 24, magnesium 25, and magnesium 26. So the mass number is 24, 25, and 26, because remember we talked about how this number is the mass number. The atomic number has to be the same, otherwise it won't be magnesium. So we go and we look up magnesium on the table, and magnesium is number 12. So they all have the same atomic number because they have to be the same element, but a different mass number. Remember, atomic number and number of protons is the same. So 12 protons for each one of them. Number of electrons, because they're neutral, the positive has to outweigh the negative. And if you're saying, but how do we know if it's not neutral? Eventually we'll get to those, and those are called ions. They'll have a little negative or a positive charge. We don't have any of those now. Everything we're dealing with right now are neutral atoms. So the positives and the negatives are equal to each other. The neutrons, remember, is our mass number, minus our atomic. And that's because the mass number is protons plus neutrons. Atomic number is just protons. So if I take those two and subtract them, I'm left with the neutrons. So mass number for the first one is 24. And the atomic number is 12. So we would subtract those and get 12 neutrons. The next one, the mass number was 25 minus the atomic number 12, and we get 13. And the last one's 26 is the mass number, minus 12 for the atomic number, and we get 14 neutrons. So the same, we see that the atomic number is the same, the number of protons is the same, and what's different, we see the mass number is different, and the number of neutrons is different. And that's how we define an isotope. So, are all atoms of an element the same? No. They could have a different mass number or a different number of neutrons, but they are always going to have the same atomic number and the same number of protons.